of 30-day LeetCoding challenge, and this is like the second day of the challenge, which is like happy number. And let's read the question together. So happy number. Write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the square of its digit and repeat the process until the number equals 1, where it will stay or it loop endlessly in a cycle which does not include 1. Those numbers for which this process ends in 1 are a happy number. Return true if n is a happy number and false if not. So this question is easy but hard at the same time. And the reason that it's easy is because they basically like tell you what you're supposed to write in your code in order to find the solution. But the hard part is like to prove what they said right here. Like, how do we know that an input n is always bound to the either like 1 or it will like loop back to like a previous number that we have seen before? Like, what if that n number keep like bouncing higher and higher, that never like find a boundary? Maybe it's like approaching a negative infinity or approaching positive infinity. I don't think it should approach negative infinity. But is there anything that we can assure or guarantee that this number will not like increase exponentially? I mean, the question kind of tells us that it will not. It will loop endlessly. It will loop back to like a number. So like for this example, like when the input is 19, it will bounce to like 1. So, and we want to return true because this is like a happy number. So we start with 19 and then we take the square of those two digits, 1 and 9, and add them together, we get 82, and then we keep doing it until we get 1. And the other case is, for example, when n is equal to 4, we would add 4, so we will get 16. And then once we get 16, we add 1 and 6 and square those two, and we get 37. And then we get 58, and then get 89, 145, 42, and then 20. So like once we get 20, we will loop back to 4. So it will the sequence will go back up here. So it will loop around this number 4, 16, 37, 58, 89, 145, 42, 20, and 4. But the hard part that makes some of you guys or even me to think about this problem is like how we are so sure that every n number always loop back. And I believe there's a proof like in the solution. I think it used to be unlocked, but now for some reason it's locked. I'm not sure. There is a proof that mentioning that like if you take a digit of a number and like square them and add them up, they will either bounce to 1 or like bounce to like or loop back to a number. So if we just follow the instruction that told us right here, so starting with any positive integer, so starting with n positive number, replace the number by the sum of the square of its digit and repeat the process until the number equal to 1, or loop endlessly in a cycle. So what we want to do is we want to have a bucket or like a set to record what we have since, like what number we have since. So like for this particular example right here, down here, if n is equal to 4, so we want to add 4, and then we calculate the square of its digit, so let's get 16, and then we put 16 in since, and then we put 37 in since, 58 in since, and if we see like a number that we since before, we will return 4. So in this case, it go back to 4. 4 square is so since we already since 4, it means that this number will like loop around endlessly. So here is like the code that I already written. So I have a loop, All right, here I'll just check if n is equal to 1, um, and n will get update for each iteration. We erase this print statement. So if n is equal to 1, I want to return true. If n is in the scene set, I want to return false. And if the number is not equal to 1 or it's not in scene, I want to add it to scene set. And then I want to set the summation. So this summation is stored like the square of each digit. So as you can see here, it's the summation. So when I do like mod 10 here, I always take the last digit of the number. So for example, 16 here, I will get 6. And then when I divide by 10, I will get just 1. So 1 is still greater than 0. And then 1 mod 10 will give me 1, and 1 square just 1. And then I will update my n value. So go back. So like this, it's keep running the whole time until I return. And then it keep going through the process. So there's like only two cases, either like the n bounds to 1 or it bounds to the number we already sent. So that's basically it. And if we run the code, it should pass all the test cases. Yes, accepted. All right, I hope you guys find this tutorial useful. Thank you for watching. Bye bye.